Okay, so today what we're going to get into is solving these trig equations. Since I know you had so much fun proving them and simplifying them, but I think this is going to be a little bit easier for you and a little bit, I guess, something you can handle. So I guess let's go ahead and get into it. All right, so sine of pi over 6, cosine inverse of square root of 3 over 2, tangent inverse of 1. These are things we should know by now. Okay, these are things that we need to know the trig ratios. We need to know those special right triangles. So what I want you to do is take 30 seconds or so, see if you can get these right. Pause the video and then restart it here in a second and see if you can get them. See if you know what they are. Okay. Okay. So now looking at sine of pi over 6. Okay. Sine of pi over 6 is a sine of 30 degrees, which is, if I can get my pen right, okay, which is going to be 1/2. Okay. Cosine inverse, remember inverse is an angle measure. Okay, that's really what we're going to be looking at here. That's what we're going to be getting at, is trying to find these angles. Okay, so the cosine inverse is square root of 3 over 2. Which angle has that trig ratio? And it's going to be 30 degrees or just pi over 6. Okay, then tangent inverse of 1, again, we're looking for an angle. Okay, tangent inverse of 1 is 45 degrees or pi over 4. Okay, so if you need to refresh yourself on that, make sure you do, but you've got to know all those angles. Okay, all the reference angles, all those major trig function or special right triangle angles. Okay, so first key point of the day: do not divide trig functions to solve. You've got to find a way to move them all to one side and then factor, do something with them, but don't divide them. Okay, you'll lose answers that way. You end up uh, getting extraneous answers. It's just not a good way to go. So again, this, not what you would do first. Okay, this over here on the right is what you do first. Okay, so again, I repeat, we get this every year. Do not divide trig functions to solve. Just find a way to move them to one side without dividing. Okay, so again, this, no. Okay, this is your first step. That's what I would do. Move everything over to one side. Okay, so now that we've done that, let's continue to look at this problem. Okay, so now I've got this sine squared x minus sine x equals 0. So what I'm going to look to do here is to factor. Okay, find something in common. So they both have a sine x, right? So that's something I can pull out. I can pull out sine x, and then I leave what's left behind. So sine squared divided by sine is sine x. Okay, and then sine x divided by sine x is minus 1. Okay, now just like you did in algebra, okay, just like you've done in the past, you can set each factor equal to what's over here on the right side. Okay, so I'm going to take sine x, set it equal to 0. Okay, then I'm going to solve this one. Sine x minus 1 equals 0. So sine of x is going to be 1. Okay, so now what you've got are the trig functions, but now I need to find an angle. So how do we find an angle? We take the inverse, right? So that'll cancel out and I'll just have x. So really what I'm looking for here is going to be x equals sine inverse of 0, and this is going to be x equals sine inverse of 1. Okay, so these are going to be angles. That's what I'm looking for. Okay, so again, whenever you solve these, you'll end up solving them between 0 and 2 pi, right? From our unit circle, okay? So from here, okay, so from 0 all the way around to 2 pi, okay? Sometimes you'll see that written like this, where they put theta in the middle, okay, and they go, it's got to be greater than or equal to 0. Okay, greater than or equal to 0, but less than 2 pi. Or sometimes you'll just see it like this, where it's a bracket 0 to 2 pi. That just means find all the angles, okay? Find all the angles that are going to be true for that situation, right? And this really needs to be a parenthesis, okay? So, now, okay? So now we're going to do that. Sine inverse of 0, where is sine 0? Well, sine is 0 on the x-axis, right? Because this is 1, 0, and this is negative 1, 0. So this one has, x has two answers. X could be 0 degrees, or x could be 180 degrees. That is, radians would be 0 radians or pi radians. Okay? But then we're not done. We've got to look over here at 1 because there's another point like this. And where that happens is on the y-axis, right? Because this is my y value. So that's going to be 0, 1. So it only happens once up there. So x is going to be 90 degrees or pi over 2. Okay? These are the answers to that equation, that trig equation. Okay? All right. Now, okay, so moving on to our next point. Okay? So what we're looking at here is that every answer you come up with, see, you could have multiple answers. 1, 2, 3, 4, probably 4 is the max at this point. What we're looking at is that every answer has to be true for the entire thing. Okay, if one answer is not true for the entire thing, then it's an extraneous solution. Okay, and what I mean by this is, say you came down to something like this, where it was, okay, where you got cosine of x equals 0, and then you ended up with the square root of 3 tangent of x equals 1. Okay, so if I'm trying to find this, this ends up being tangent of x equals 1 over the square root of 3. So if I'm trying to find the angle measures here, okay, when is cosine 0? Okay, well, that happens twice, right? At pi over 2, because this is 0, 1, and at 270 degrees because that's 0, negative 1. Okay, so this happens at pi over 2 or 3 pi over 2. Okay, but we've got to just kind of hold on to this and be careful, because we could have an extraneous solution here. Okay, now tangent x of 1 over the square root of 3, okay, that is going to 30 degrees. So x is going to be 30 degrees. But it also could be, right, because remember, in the first quadrant, all of the trig ratios are positive. In the second, sine is positive. And the third is tangent. And then the fourth, cosine is positive. So it's positive here, but it's also positive in here. So the reference angle here, if I had a 30-degree reference, right, like that, this is also going to be x equals 210 degrees. Okay, so this is where we have to be careful, because I've got to plug these back in for these tangent x to make sure it would all still work. Okay, so if I said tangent x, or I'm going to replace x, okay, I'm going to replace x with pi over 2. What's that going to equal? Okay, well, pi over 2 is up here. Tangent is y over x, right? That's going to be 1 over 0. Well, 1 over 0 is undefined. Okay, because remember, tangent at 90, okay, at 90 and at 270 is undefined. Okay, so these solutions would make this untrue. Okay, make tangent x untrue. So these answers are no good. These are my only two answers if I came out with a situation like that. Okay? All right, so as we move along here, we've got to kind of keep that in mind. Okay, so now let's take a look at number 5 on that worksheet number 3 that the sub has passed out to you. Okay, so it says sine x plus cosine x equals 0. So this is one of those situations where it doesn't look like I can factor anything, but remember, you can always still factor out, because a sine and a cosine, to create something else like a tangent or a cotangent or something like that. So say we just take this and we factor out a sine. We pull a sine out. Okay, so sine x, right? Now, if I pull that out, I'm going to divide this by this. Sine x divided by sine x is 1. Okay, and then cosine x divided by sine x is plus cotangent x. Okay, equals 0. So like we did in the previous problem, we need to set these both equal to what's over here on the right, which is 0. So I'm going to have sine of x equals 0, and then 1 plus cotangent x equals 0. Okay, I solve these. I end up with cotangent x equals -1, and this one's still okay. So now I want to know what angle I can put in here that will make these true, and then make the entire thing true, right? This has got to be true as well. It can't be undefined. Okay, so when is sine of x equal to 0? Okay, what would x be? X is going to be 0 degrees, okay, and then 180 degrees, or 0 radians and pi radians. Okay, now we look at cotangent of uh, -1. When does that happen? Okay, so remember your unit circle. Where is tangent negative? Okay, we've got all of them are positive there, so that's no good. Only sine's positive, so in the second quadrant, so I've got a second quadrant angle. Okay, so what would make cotangent just a positive one? Well, that's 45 degrees. So the reference here, 45, 180 minus 45, okay, is going to be 135 degrees. So I've got x equals 135 degrees, okay, or 3 pi over 4. Okay, and then in the third quadrant, tangent's positive, so that can't be it. And then in the fourth quadrant, cosine's positive, so that is going to work. So again, the reference here, 360 minus 45, is going to be x equals 315 degrees, or it's going to be 7 pi over 4. Okay, now if I plug these in, like if I said, okay, if I put pi in for cotangent of x, okay, well, if I look at the cotangent of 180 degrees, where I've got this, right, -1, 0, if I put that in, okay, cotangent is x over y, okay, so cotangent of 180 degrees equals -1 over 0, so this is going to be undefined, right? So this answer doesn't work. Well, if it's straight across here, this answer also isn't going to work. So the only two answers I have for this problem are 3 pi over 4 and 7 pi over 4. Okay? All right. So we'll keep rolling. If you want to pause and rewind that to make sure you got it, go ahead and do so. But otherwise, we're just going to kind of keep going on here. Okay. So two more examples. I promise. Hang in there. We're getting there. We're getting close. Okay. Now, this looks fairly simple, right? Fairly simple and straightforward, but you got to beware of the ones that look too simple. Okay. So the first thing I would do here, okay, so now that I've got tangent squared theta equals 3, I've got a constant equals something over here. What I would do, okay, is get rid of this squared. So how have we gotten rid of a squared in the past? Okay, what you're looking at doing is taking the square root. Okay, but the problem is I forgot something. You've got to do plus or minus. Okay, so plus or minus. So this is going to create more solutions, right? So I'm going to end up with tangent of x equals plus or minus the square root of 3, which really sets up two separate situations, right? I'm going to have tangent of x equals the square root of 3, and tangent of x equals negative square root of 3. Okay, when this happens, okay, we got to go back to our circle. Okay, okay, so looking at our circle, all right, when is tangent the square root of 3? Okay, well, it's this 60-degree angle, right? Because we've got 1/2 and then square root of 3 over 2. Okay, so if I put y over x, that ends up being square root of 3. So I know that x is going to be 60 degrees. Now, where else is it positive? Well, it's positive down here, right? Because of this all students take calculus idea, right? I've got to have a reference angle of 60 degrees in the third quadrant. Okay, so that's going to be x equals 240 degrees. Okay, but then I also have the negative version, so that's going to be in the second and fourth quadrants. So again, a reference angle of 60 in the second quadrant is going to be x equals 120 degrees, and in the fourth quadrant, x is going to be 300 degrees. Okay, so these four answers are what I've got. So if I forget the plus or minus, I've really lost half the question. Okay, so don't forget, fairly easy problem, but it always gets people when they forget the plus or minus on the square roots. Okay, we're almost there. All right, last example. You're almost done. Okay, so when we look at this, okay, um, you're probably going to need a calculator for this one. Okay, because again, with that inverse deal, some of these we're going to end up with not having the special right triangle angles. Okay, so this is where you're going to have to use your calculator to find the inverse. Okay, and so for that situation, I'll let you know, but for right now, we are going to find the angle between when it's greater than or equal to 0 and less than 360. So whenever it does that, it tells you, whenever it gives you it in um, this range, it's telling you it wants to use degrees. Whenever we put it between, when theta between greater than or equal to 0 and less than 2 pi, okay, that's going to be radians. So degrees and then radians. Okay, so we're going to look at this in degrees. Okay, so the first thing I would do here, instead of just pulling out a cosine, okay, what I would do is go ahead and pull this 2 over. Okay, and you'll see why here in a second. We've got 3 cosine squared x plus cosine x minus 2 equals 0. Okay, so now what does this kind of look like? If I took the cosine squared x's away and I just had this 3x, okay, 3x squared plus x minus 2. We could factor that, right? Well, we can still factor it. It's still a quadratic, okay? We can still factor it. Okay, so what you're going to end up doing here is just factoring it the way you would. So if I've got 3 cosine squared x plus cosine x minus 2 equals 0, I'm looking for two numbers that multiply to -2 and a 3 that would add to 1. So I need the factors of 3 cosine squared. So that's going to be 3 cosine x and then cosine x, and then factors of -2 that's going to make this work. Okay, I would do 3 cosine x minus 2 and cosine x plus 1. Okay? Okay, so what we're going to do here is actually solve these for the x, right? So I'm going to have 3, okay, 3 cosine x minus 2 equals 0, and cosine x plus 1 equals 0. Okay, so this becomes cosine x equals 2/3, and cosine x equals -1. Okay, now this one here, okay, I can do with a special right triangle, right? Or my quadrantal angles from my circle. Okay, cosine of -1, the only time that happens is down here at 270 degrees, right? Because if I do that angle, because this is 0, or sorry, not 270. Sorry, it's going to be actually 180 degrees. Okay, so here, I'll redraw that. Okay, this cosine is -1 at 180 degrees. So I've got -1, 0. Okay, so this x is going to equal 180 degrees, right? Because we said we were doing it in degrees. Now, cosine x of 2/3, that's not a special trig function. That's not a trig ratio that we've used or memorized, but we can still find it by using our calculator. And how do I get rid of a cosine? Okay, remember that's taking the inverse cosine. So x is going to equal inverse cosine of 2/3. Okay, and when you put that in your calculator, make sure it's in degrees. Okay, and you end up with 48.19 degrees. Now that's my reference, right? Okay, so it could be there, but where else is cosine positive? Okay, cosine is also positive in the fourth quadrant. So if that's my reference, I'm going to do 360 minus this 48.19, and that gives me 311.81 degrees. Okay, so now what I want you guys to be able to finish up today is this worksheet number 3. The sub should have an answer sheet to it, so if you want to check your work, check your answers, you can do so. If you want to look this up on the web, the sub um, has the website address. It's on YouTube, so you can look it up on YouTube. You can get the address from the sub so that you could go home and watch it and be ready to go tomorrow. So hope this helps. Hope you guys are doing all right. So um, good luck with the rest of this, and I'll see you on Monday.